Today we're going to look at some proofs of circle theorems. The one I'm going to look at is to prove that the angle at the centre is double the angle at the circumference. In other words, prove that the angle ACB is twice the angle ADC. Now, in order to do that, we need to put in a construction line. We want to join D to the centre C and then produce it to meet the circumference at E. So we've constructed the line DCE. Then we need to label these angles. So we'll give the angle ADC the letter X and the letter BDC the letter Y. It's entirely up to you what you label those as, X and Y or alpha and beta, whatever you choose. So then we've got, going back to this circle, we've labelled this angle X and this angle Y. But we know that in a circle, the distance from the centre to the outside edge, the circumference, is the same all the way around because this is the radius of the circle. So we know that DC equals CA. So this is an isosceles triangle. And so the angle here at A, CAD, must be the same as angle ADC. They're both equal to angle X. And similarly, on the other side, we have an isosceles triangle DCB, and this means that angle CBD is also angle Y. So when we're writing it out, we'd have to say that AC equals CB equals DC because they're radii of the circle. That means that triangle ADC is isosceles, triangle BCD is isosceles, and so we have that angle CAD is X and angle CBD is Y. The next step in this proof, we're coming back to what we're trying to do. We're trying to prove that this angle is twice this angle. So now we want to see if we can work out what this angle is here, ACE, and angle BCE, and see if we can connect them to this one. So in a triangle, if you produce one of the sides, the angle between that produced side and the side next to it is called the external angle of a triangle. And the external angle is the sum of the two interior opposite angles. So this angle here, ACE, is x plus 2x, x plus x, which is 2x. And similarly on the other side, angle BCE would be the sum of y plus y,